Now we are going to learn how to identify the Jordan canonical form of the matrix. Now this is the matrix given 3 0 0 0 0 3 1 0 0 0 3 0 0 0 0 3. So how to find the Jordan canonical form? Now above the main diagonal we have 1. See here, look at the first two rows, here 3 and in the second row also 3 but no 0, so we can't form a Jordan canonical form. Look at this, here 3 main diagonal 3 3, second and third row 3 3, above this we have a 1, so this is the Jordan canonical form. So first we will find the characteristic polynomial, then we will form Jordan canonical form. Now characteristic polynomial, how many roots? This is the 4 by 4 matrix, so we have 4 roots and the minimal polynomial of A is given by, so as I said, the one must be present in the above the main diagonal. So this here only 3, so this is a separate block and this is also a separate block and this is also a separate block, and this block is called the Jordan block since above the main diagonal we have 1 here. So if we see these type of matrix, that is called a Jordan canonical form of the matrix. Here this is these are all blocks, this is 1 block, this is 2 blocks and 3 blocks. Here the characteristic polynomial is the roots of the matrix A is called the characteristic polynomial. So here x minus 3 is equal whole power 4 or the characteristic polynomial. To find the minimal polynomial we need to find the Jordan block, which is the minimum block will form the minimal polynomial. Here this is the Jordan block and its degree is 2. It's a 2 by 2 matrix, so the power of the minimal polynomial is given by 2, so it forms the minimal polynomial. Once you find out the Jordan canonical form of the matrix, you will get the minimal polynomial. So for this matrix we have the characteristic polynomial x minus 3 the whole power 4 and the minimal polynomial is x minus 3 the whole square. So here the characteristic polynomial and the minimal polynomial are not equal, so it is not diagonalizable. Once the characteristic polynomial and the minimal polynomial are equal, we can say it is diagonalizable. So let's see the second example. Here this is the matrix given. Here I have marked the blocks, so these are all Jordan blocks since above the main diagonal we have 1, so we have the Jordan blocks here. How many blocks? 1 2 3 Jordan blocks of different dimension. This is 3 dimension, this is 2 dimension and this is also a 2 dimension. So the characteristic polynomial of this matrix is given by, here what are all the characteristic roots? X minus 2 the whole cube and x minus 6 the whole square, x minus 4 the whole square. So the characteristic polynomial is given by x minus 2 the whole cube, x minus 6 the whole square, x minus 4 the whole square. To find the minimal polynomial, as I said, once the Jordan blocks are formed, the degree of the Jordan blocks are said to be the minimal polynomial. Here x minus 2 the whole cube is the minimal Jordan block, so it is the minimal polynomial. Here x minus 4 the whole square and it is a 2 dimension and this is also a 6 dimension, so x minus 6 2 dimension, x minus 6 the whole square. So the characteristic polynomial and the minimal polynomial are equal, so we can say it is diagonalizable. So we have formed the Jordan blocks. From these Jordan blocks, we have found out what is the characteristic polynomial and what is the minimal polynomial, and comparing the characteristic polynomial and the minimal polynomial, we will get we will conclude that it is diagonalizable. Once the characteristic polynomial and the minimal polynomial are equal, it is said to be diagonalizable. Diagonalizable. Okay, so now look at the third example. So here, this is the block here. This is the block. As I said, then above the diagonal element we have 1 here. You should not mark here, since we have in the third row also 2, above it we have 1. So you need to mark in the 3 dimensions. So, and in the fourth and fifth column we have 6 as the 6 in the diagonal 6 as the diagonal element, and above it we have 1, so it is also a Jordan block, and this is also a Jordan block. So the characteristic polynomial is here how many roots? X minus 2 the whole power 5 and x minus 6 the whole square is the characteristic roots. To find the minimal polynomial, we have already I told you, no, we have 2 blocks, Jordan blocks here, in that which is minimum, and here this is the minimum block. So we have x minus 2 the whole square, x minus 2 whole square, and x minus 6 the whole square is called x minus 6 the whole square is the minimum block. Here the characteristic polynomial and the minimum polynomial are not equal, so it is not diagonalizable. So this is the tricks we have found out how to find the how to form the Jordan block, and how to identify the characteristic polynomial and the minimal polynomial.